Hey friends, have you ever wondered, are we humans the only ones in this universe? Or is there intelligent life out there somewhere? If aliens do exist, they must be wondering the same thing. Are they alone? How can two intelligent species in the universe communicate with each other? To explore this idea, NASA has started several projects to send messages to aliens. Back in 1977, NASA launched the Voyager 1 spacecraft with a very clear mission. Its mission was to explore our solar system, from the outer planets all the way to the edge of the solar field, and maybe even beyond that. Simply put, it was an interstellar mission. You know, our galaxy is home to millions of solar systems. The space between these solar systems is called interstellar space. So far, NASA has launched only 5 spacecraft for interstellar exploration: Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. Out of these 5, only 2 have actually reached interstellar space because it takes an incredibly long time to leave the solar system. And those 2 spacecraft? They're very special. They are Voyager 1 and Voyager 2. These spacecraft took an incredible tour of the solar system, giving us stunning photos of Jupiter, Saturn, Uranus, and Neptune. In fact, Voyager 2 is the only spacecraft to have visited Uranus and Neptune up close. Voyager 1 journey has been so long that it's now officially the farthest man-made object from Earth. As of October 2024, Voyager 1 and Voyager 2 are 24.7 billion kilometers away from Earth. But the coolest thing about these 2 Voyagers is that they're carrying special messages for aliens. These messages are traveling with them through space, in the hope that one day they might be found by extraterrestrial life. Through these messages, we aim to tell aliens a little about who we are. So, what's in these messages? What secrets have humans shared with the universe? Let's dive into the fascinating story of the Voyager missions in today's video. But before we get into, please subscribe. Let's go back to 1965. A NASA engineer noticed something interesting: a unique geometric alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, would happen in the late 1970s. This alignment only occurs once every 175 years. This rare arrangement meant that a spacecraft could use the gravitational pull of these planets to travel by them, using very little fuel and time. This technique is called gravity assist. It uses the gravitational force of a planet to change the speed and direction of a spacecraft. Using this principle, NASA planned the Voyager 1 and Voyager 2 missions, which is why 1977 was chosen as the year to launch these spacecraft. According to the mission plan, Voyager 1 would fly by Jupiter and Saturn, focusing on Saturn's largest moon, Titan. Meanwhile, Voyager 2 was set to pass by Jupiter, Saturn, Uranus, and Neptune. Both spacecraft were designed similarly. They were powered by 3 radioisotope thermoelectric generators. They didn't have solar panels because, beyond Mars, solar energy becomes almost useless. As you move further out, the sun's rays don't have enough energy to generate power. Since their mission was to venture far beyond the solar system, they relied on the radioactive decay of plutonium for power. When plutonium decays, it releases heat, which can be converted into electricity. That's how the radioisotope thermoelectric generator works. Both probes were also equipped with 10 scientific instruments, including a 2-camera imaging system for taking pictures, a spectrometer for measuring hydrogen levels, another spectrometer for detecting ultraviolet activity, a magnetometer for studying planetary magnetic fields, and a high-gain antenna for communicating with Earth. There were also smaller instruments to measure radiation levels. Interestingly, Voyager 2 was launched before Voyager 1, on August 20th, 1977. Voyager 1 followed 16 days later, on September 5th, 1977, from NASA's Kennedy Space Center. Although launched later, Voyager 1 took a shorter, faster route and was the first to reach Jupiter in March 1979. During this time, it captured an amazing time-lapse of Jupiter, made up of 66 photos taken after each rotation of the planet, which takes about 10 hours. This was the first time we got such clear pictures of Jupiter and its moons. It was during this exploration that scientists discovered Jupiter's rings. Many people think only Saturn has rings, but Jupiter does too. They're just faint and harder to spot without close observation. Jupiter, its moons, and its rings together form what's known as the Jovian system, named after Jove, the Roman god of the sky and thunder, another name for Jupiter. Jupiter, Saturn, Uranus, and Neptune are all gas giants with rings and many moons, which is why they're called Jovian planets, or Jupiter-like planets. While exploring the Jovian system, Voyager 1 also discovered active volcanic activity on one of Jupiter's moons. This was the first time humans saw volcanoes on another celestial body. Before Voyager 1's visit, we believed Jupiter had 13 moons, but after its flyby, we discovered 2 more. Later, when Voyager 2 approached Jupiter on July 9, 1979, it got even closer and discovered yet another moon. Thanks to these missions, Jupiter's known moons increased from 13 to 16. But here's something even crazier. Today, we've identified 95 moons around Jupiter. That's right, 95. About a year and a half later, on November 12, 1980, Voyager 1 reached Saturn. By this point, its speed had increased so much that Voyager 2 took another 9 months to catch up. When Voyager 1 reached Saturn, it discovered 3 new moons: Atlas, Prometheus, and Pandora. Yes, Pandora, just like the alien world in the Avatar movie, but in reality, it's one of Saturn's moons. At the time, Saturn had about 15 known moons. Today, we've discovered 146 moons around Saturn. Voyager 1 captured many images of Saturn's moons, and one of the most fascinating is Titan. Titan is the only place in our solar system, apart from Earth, where there's clear evidence of liquid water. That's why it's often featured in science fiction as a place where aliens might live or where humans could survive.
Titan could become our home.
After Saturn, the paths of Voyager 1 and Voyager 2 diverged. Voyager 2 continued to Uranus and Neptune, becoming the only spacecraft to pass close to these planets. It reached Uranus in 1986 and Neptune in 1989, sending back incredible photos. Voyager 1, on the other hand, left the ecliptic plane, the flat plane where most planets orbit the Sun. If you look at the ecliptic plane in 3D, it appears like a flat disk. Voyager 1 moved out of this plane and sped up. Today, it's zooming through space at a staggering speed of 60,000 kilometers per hour. In this diagram, you can see where Voyager 1 and Voyager 2 are now. On January 1st, 1990, Voyager's interstellar mission officially began. Its goal was to leave the Sun's influence. Then, on February 14, 1990, Valentine's Day, Voyager 1 took the famous pale blue dot photo. At that time, it was about 6 billion kilometers away from Earth. In the photo, our planet looks like a tiny blue speck. This photo was part of a family portrait of the inner solar system, including Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. Mercury and Mars weren't visible because of the sun's glare, and Pluto was too small to show up. After taking these photos, Voyager 1's cameras were turned off to save power and memory. There wasn't much else to photograph in the darkness of interstellar space. Years passed without major updates about Voyager 1. In 1998, it was confirmed as the farthest man-made object from Earth. In 2004, scientists announced it had crossed the termination shock, a point where the solar wind becomes weak. Solar wind is a stream of charged particles from the sun that forms a protective bubble around the solar system called the heliosphere. The heliosphere shields us from interstellar radiation. When you reach its outer boundary, the solar wind weakens. This is the termination shock. After that comes the heliopause, followed by interstellar space. On August 25, 2012, Voyager 1 left the heliosphere and entered interstellar space. Scientists had to reevaluate their understanding of this boundary. It's now thought to be a gradual transition zone rather than a clear-cut line. It took 22 years to reach interstellar space, and NASA spent 8 months confirming this historic achievement. In September 2013, they announced that something made by humans had crossed the borders of the solar system for the first time. But how did we know that Voyager 1 had crossed the boundary? Well, we found out because of its plasma wave instruments. Between April 9th and May 22nd, 2013, a powerful solar eruption was recorded in Voyager 1. Because of this eruption, the electrons near Voyager 1 started vibrating. Researchers noticed that the electron density around Voyager 1 had increased compared to the heliosphere. This helped us understand that Voyager 1 had reached interstellar space. But how is this possible? The electron density outside the solar system is actually higher than inside. This is because, in the heliopause region, there is a big dip in the solar wind. When Voyager 1 was in the heliopause region, the electron density was very low. Then, as soon as Voyager 1 reached interstellar space, a sudden spike was observed in the electron density. The difference is that the spike in electron density before the heliopause was due to solar wind, while the spike after the heliopause was due to interstellar wind. All of this was made possible thanks to the high-gain antenna. All the photos, findings from the instruments, and mission-critical information were being sent through this and received on Earth by NASA's Deep Space Network stations. These Deep Space Network stations are amazing in themselves. They're located in 3 places on Earth: California, Madrid, and Australia. As you can see in this animation, these 3 locations cover most of the Earth's area. When the researchers got all this data, they worked backwards to find out exactly when Voyager 1 entered interstellar space, and they confirmed it was on August 25th, 2012. Coincidentally, this was the exact day when Neil Armstrong passed away. That was all about Voyager 1. But what about Voyager 2? Voyager 2 also entered interstellar space, but 6 years later, on November 5th, 2018. As of now, only 2 space probes have made it this far. Voyager 2, like Voyager 1, also carries a message for any aliens out there. While these 2 Voyager missions have set many records, they weren't the first to send a message to aliens. Pioneer 10 and Pioneer 11 did the same thing earlier. In fact, the messages sent by Voyager to aliens were the same ones sent by Pioneer 10 and 11. The only difference is that Voyager used newer technology to send the messages. The Pioneer plate is a small gold anodized aluminum plate installed on the Pioneer 10 and 11 spacecraft. This plate has engravings that tell aliens about Earth. NASA called it the Mark of Man. The plate is only 15 to 23 centimeters long, but it has 5 diagrams engraved on it. It gives information about our location in the galaxy. In the middle, there's a radial diagram, which is a map showing the position of the Sun in relation to 14 pulsars. Pulsars are collapsed stars that spin rapidly and emit regular pulses. To understand the map, the aliens would need to already know a bit of this science. On the lower part of the plate, the planets of the solar system are shown, with the Sun on the far left. All the planets are lined up after the Sun, and there's an arrow pointing to the 3rd planet, showing that this is where the spacecraft came from. On the right side, there's a silhouette of the spacecraft, along with a drawing of a man and a woman. This is meant to show that humans look like those who created the spacecraft. NASA said that this interstellar slab shows the spiritual insight of humanity. The plate is pretty basic, so if aliens were to see it, they wouldn't understand much. That's why the things sent in the Voyager missions were much more detailed. The messages sent with the Voyagers are actually 12-inch gold-plated copper discs, also called phonograph records. These include both voices and images. There are 2 such records, one on each of Voyager 1 and Voyager 2. Let's take a closer look at what's on them. The phonograph, also known as a gramophone, is a flat disc that stores sound. It was quite popular in the 1970s when the Voyagers were made. The grooves on these discs are arranged in a spiral pattern where sound waves are encoded. When a needle is placed on the disc, it vibrates and sends the sound through a box, which makes the sound audible. Today, we have turntables, but the concept is still similar. The record sent to the Voyagers is called the Golden Record. The contents of this record are divided into 4 sections. The first section is called Scenes from the Earth, which includes 115 images and diagrams about the species on our planet and our world. It also has basic definitions of mathematics, chemistry, and physics. The second section is Greetings from the Earth, which has greetings spoken by humans in 55 different languages. It also includes a printed message from President Jimmy Carter and UN Secretary General Kurt Waldheim. To understand this, aliens would need to know English. The third section is Music from the Earth, which has 28 audio recordings of music from different cultures and time periods. It includes classical music from both Eastern and Western traditions. The fourth section is Sounds of the Earth, which contains 21 different natural sounds, human activities, and machine sounds. If aliens want to hear these sounds, they need to know how to operate the phonograph. NASA made sure not to write the instructions in English or other languages, because what are the chances that aliens would understand those languages? Unfortunately, the instructions are shown in diagrams, and as you can see, even humans might have trouble understanding these instructions. But still, this is the best attempt NASA made to explain how to play the phonograph. Now, if aliens want to hear the music or see the images, they'll need to decode the data. Back in 1977, there was no way to store images on analog discs, like we store them today with JPEGs. The Voyager computer systems could only store 69 kilobytes of data. That's only 0.07 megabytes. To fit 115 images, NASA had to get creative. They projected the photos onto a screen and recorded them with a television camera, converting the video signals into audio waveforms. These images are stored as audio waveforms on the discs, so aliens would need to reverse the process to see them. The Golden Record comes with instructions for this decoding process, but the technology is so complicated that it would take a whole separate video to explain it. So, let me just show you the images stored on the Golden Record. Once the images are decoded, the first image is a white calibration circle. It's a simple black and white drawing showing two things: the shape of the record and that the decoding was done correctly. After that, there are photos of basic math, physical units, and quantities, followed by diagrams of the Sun and the 9 planets at the time. There are also individual photos of Mercury, Mars, Earth, and Jupiter, with some additional explanations using symbols, mathematical definitions, and chemical formulas. For example, one photo shows the composition of Earth's atmosphere with 78% nitrogen. There are also pictures of DNA structures, explaining how genetic information is passed down. There's an image showing cell division under a microscope, and after that, 20 images showing human life. Some photos show human abilities, like how we use our mouths to eat and drink. Interestingly, none of the images show any of the negative aspects of humanity. There's no mention of war or conflict. The pictures only show the hopeful, positive side of humanity, an ideal version of us. As Carl Sagan wrote in his book Murmurs of Earth, the Voyager Interstellar record represents this. Now, the big question is whether any Voyager spacecraft will ever reach an alien species. And even if they do, will those aliens have enough intelligence to decode the message? What do you think? Feel free to share your thoughts in the comments below. For now, Voyager 1 is traveling at a speed of 61,198 kilometers per hour, about over 25 billion kilometers away from Earth, deep in interstellar space. Unfortunately, its power supply is slowly running out, and scientists believe that by 2025, we'll lose contact with it. But the communication with Voyager and its Golden Record will last forever. This incredible journey of the Voyagers continues to inspire us to explore the unknown. What lies beyond? Could these spacecraft one day bring us closer to answering the ultimate question? Are we alone in the universe? If you like it, comment, share, and subscribe. Thank you for watching, and we'll see you in our next exciting video.